Hi. So I have had a few emails saying that you guys are a little bit nervous about your test on Wednesday. And so I wanted to talk to you through this video about the test and what I'm expecting. So this is on Wednesday, October the 8th. So first of all, there are going to be multiple choice questions, and they are only on the Bohr model of the atom and the electromagnetic spectrum. So you had a quiz on this material last week, and a lot of you did really well. It was things like, what's the wavelength of light that's given off when an electron transitions from n is equal to 2 to n is equal to 1, or which type of electromagnetic radiation has the highest frequency, and so forth. And so I feel pretty good that you guys are ready for those multiple choice questions. You've had a quiz, and we had 2 warm-ups with questions, and some of the questions on the test are very similar to the warm-ups. So go back to those warm-ups, look at those, study with your neighbor in class, and study your quiz. In both classes, several students got hundreds on that quiz, so they should be able to help you out. All right, the calculations, I think, is what's probably scaring you the most. So the first calculation that you have to know how to do is converting prefixes. You do have to have the definitions for a few of the prefixes memorized. So kilo or kilo is 1,000. Centi is 1 times 10 to the negative 2. Milli is 1 times 10 to the negative 3. Micro is 1 times 10 to the negative 6th, and nano is 1 times 10 to the negative 9th. Now you do have to know those. And then you're going to see a problem like this. It says convert 300 kilograms to grams. Well, the first thing you do is start with what's given. So put down 300 kilograms. Get that unit there. Then in the denominator, okay, so then you would draw that box that we're used to drawing. You put in your box, and in the denominator you put in the unit kilogram, and that way the kilograms will cancel. Okay, so kilogram is in our denominator, and then you put in the numerator the base unit without that prefix. So the kilo is here, and now you put grams up here. What's the definition of kilo? You put a 1 where the prefix is, and the definition with the base unit, kilo is 1,000. So the way you do this problem is 300 times 1,000 is 300,000. Let's try another problem. Convert 595 nanometers to meters. Start with what's given. 500 nanometers, that's in the numerator. Now we draw our little box over here, and in the denominator we put nanometer, and that way it will cancel with what's over here. Where is the prefix? Here it is. Put the number 1 with nanometer. Where there is no prefix, put the base unit, meter, and the definition of what nano is, which is 1 times 10 to the negative 9th. So this problem, it would be 595 times 1 EE to the negative 9th. And what you come up with, if you put that into your calculator, should be 5.95 times 10 to the negative 7th. All right, let's do one more. 3,000 liters to milliliters. All right, start with what's given. Step 1, 3,000 liters. Step 2, put the unit that's here in the denominator and in that box. So here it is. Step 3, we have our base unit. Put what you're trying to convert to in the numerator. So we're going to put milliliters on the top because that's what we want. Step 4, put a 1 where the prefix is, 1 milliliter, and then where the base unit is, put the definition of what the prefix is. Milli is 1 times 10 to the negative 3rd. So for this problem, it's 3,000. This number down here is in the denominator, so you divide. 3,000 divided by 1, EE to the negative 3. And so what you should get when you do this problem would be 3.0 times 10 to the 6th milliliters. All right. Let's see. So again, start with what's given. the unit that you have given, put in the denominator in the box. Then so this is the base unit, put what you want in the top. It's asking for milliliters, put it in the numerator. Wherever the prefix is in this conversion, put the number 1, and then put its definition with the base unit. Milli is 1 times 10 to the negative third. All right, now the next set of calculation problems is using this formula, c, which is the speed of light. It's a constant. It will be given to you, is equal to lambda times nu. And lambda is the wavelength unit, and it must be in meters. Must be. If it's in nanometers, you know what to do. Convert it to meters. Nu is frequency, and the unit is 1 over seconds, which can be written as seconds to the negative 1, and the name for that is hertz. And what I have done down here is I've rearranged this equation, and I've solved for frequency, that's c divided by lambda, or I solved it for lambda. Lambda is c divided by nu. The question is either going to ask you, what's the frequency? Use this formula. What's the wavelength? Use this formula. Okay, so what's the frequency of light that has a wavelength of 5.95 times 10 to the negative 7th meters? Use the equation for frequency. Frequency is c divided by lambda. So c is a constant. It's going to be given to you. Plug it in the numerator, and then the wavelength, here it is, the unit is in meters, so that's good, divided by 5.95 times 10 to the negative 7th meters. When you do that, your answer is going to be 5.04 times 10 to the 14th. All right, so guys, I just wanted to give you a little inspiration. Remember, just plug the numbers in the formula where they belong, and here you go. Uh-oh, I don't know if this is going to work for us. Let's see. Here we go.
You can do it. 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 Oh, yes, we can. And yes, we will.
Well, that was supposed to encourage you to say, yes, you can do this. Do your best job on Wednesday. Review your notes, your warm-ups and things, and you can do it.